Good day, I am Rainier Ginto, ID 123, and I will be teaching Foundational Math or FNDMATH Long Quiz 3. Basically, Long Quiz 3 revolves around trigonometry, so topics such as angles, angles of depression, elevation, and especially the trigonometric functions and trigonometric identities will be covered in this video. So now let us discuss the direct evaluation, especially if the angles or theta given are special angles. So basically, there are 5 special angles that are commonly used. These are as shown: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And yeah, like this. Their values are commonly tabulated or memorized for easier calculations. So that using this table, let's try solving this. Oh, by the way, this is in degrees also. And in our problem, it is in radians. So let's try calculating that into radians. So 0 degrees is still 0 rad. 30 degrees is 1 pi over 6 rad. 45 degrees is pi over 4. And 60 degrees is pi over 3. Then 90 degrees is basically pi over 2. I converted it using the method I've shown earlier, so let's just proceed with it. So what this would equate us to solve for, yeah, so let's just do direct substitution now. Sine pi over 3. Let's find pi over 3. This is it. Its sign is square root of 3 over 2, sorry. Square root of 3 over 2. Plus cosine pi over 4. Pi over 4 is 45 degrees, and its cosine is 1 over square root of 2 over 2. And we have tangent of pi over 6. Pi over 6 is equal to 30 degrees, and its tangent is 1 over square root of 3. Then it is going to be raised to the value of tangent of 2 pi. So what is 2 pi? Notice that 2 pi is actually just 360 degrees. And 360 degrees is coterminal with 0 degrees. So it's basically asking for the tangent of 0 degrees, which is 0. So now let's look for the value that are below. Pi over 6. The cosecant of pi over 6 is equal to, cosecant of pi over 6 is equal to 30 degrees, and its cosecant is 2. Then we have the secant of pi over 3. Pi over 3 is 60 degrees, and its secant is also 2. Then the cotangent of pi over 4. And we know that pi over 4 is equal to 45 degrees, and its cotangent is 1. So from here, we can already solve it now. So notice that the numerator is quite a mess. It's quite hard to evaluate. However, all of this is raised to 0. And when we raise any number that is not 0 to 0, it gives us 1. It's just basic rule of exponents. So the numerator is automatically 1. Then for the denominator, it is 2 plus 2 plus 1, which gives us 5. So basically, this whole problem, the answer to this is equal to 1 over 5 or 1/5. Let us now talk about trigonometric identities. These are all formulas of identities, alongside with the ones I've shown you, like the reciprocal identities or the SOHCAHTOA. So here, basically it's a lot, but yeah, you can memorize it or use a formula card if it's allowed to take note of this. I'm just gonna scroll through it, and we're gonna use it in different problems. You can actually search it up on the net if you want. We're only going to use the more common ones, like the ones on top, like the Pythagorean identities or the angle addition identities, double angle identities, those kind of stuff. Now, in order to apply the trigonometric formulas that we have learned, let's apply it in the context of proving. So let's do this one first. The first problem, it says that we need to prove that secant squared x minus secant x tangent x sine x is equal to 1. So from here, let's just start with trying to simplify this part. Let's simplify this part. So we know that secant x is equal to 1 over cosine x, and tangent x is equal to sine x over cosine x. Then sine x is equal to sine x. So let's bring up this one and just bring this down. And we multiply all of this. It actually gives us sine squared x over cosine squared x. However, we know that sine squared x over cosine squared x is just equal to tangent x, tangent squared x rather. So now we need to prove that secant squared x minus tangent squared x is equal to 1. However, let us recall one of our Pythagorean identities stating that secant squared x is equal to tangent squared x plus 1. So let's copy that. I'll mark it, this one. Let's take note of this. So we can write it as 1 plus tangent squared of x minus tangent squared of x is equal to 1. And notice that it will cancel out. Yeah, it will cancel out. So cancel this, because one is positive and the other one is negative. So we are left with 1 equals 1, which is what we are looking for. And hence it is proven. So let's now solve for the second problem of proving. It states that we have to prove this. Now to start, let us write it down. 1 minus tangent squared x over 1 plus tangent squared x equals 1 minus 2 sine squared x. Now notice that this part is actually equal to secant squared x. And it is actually one of our Pythagorean identities. Secant squared, yeah, here it is. So we can use that. So that means that the left-hand side of the equation that we are proving is equal to 1 minus tangent squared x over secant squared x. Now, what are we going to do starting from here? Well, we can actually divide this into two parts. We can do this 1 over secant squared x minus tangent squared x over secant squared x equal to 1 minus 2 sine squared x. And from here, notice that secant squared x is basically the reciprocal of cosine squared x. So we can write it as cosine squared x. And as for this one, recall that secant squared x is, recall first that the tangent squared x is equal to sine squared x over cosine squared x, while the secant squared x is basically the reciprocal of cosine squared x. So having it divided by the cosine squared x is equal to multiplying the expression by cosine squared x, like this. So now, notice that we can cancel out. So we have now in the left-hand side of our equation, cosine squared x minus sine squared x equals to 1 minus 2 sine squared x. So what do we do here from now? Well, we already have a negative sine squared x and we have a negative 2 sine squared x here. So let's try manipulating this one. And notice that we can use another Pythagorean identity here. This one, sine squared x plus cosine squared x equals 1. We try to manipulate it. On one of our identities, it says this sine squared x plus cosine squared x equals 1. What if we just transpose the sine squared x to the other side? That would give us cosine squared x equals 1 minus sine squared x. So we can just substitute this over here. And that's what we're going to do. We're going to have 1 minus sine squared x minus sine squared x equals 1 minus 2 sine squared x. And it simplifies actually into 1 minus 2 sine squared x, which is actually what we're looking for. So now we have proven the identity that, yeah, we have proven this identity that 1 minus tangent squared x over 1 plus tangent squared x is equal to 1 minus 2 sine squared x. Now let us apply our learnings in trigonometry into real life situations. We have a problem here, and we're going to discuss the angle of elevation and angle of depression. The angle of elevation basically says elevation. You're looking up. For example, your eyes are over here. Your eyes are over here, and you're looking up. This is the angle of elevation. Yeah, angle of elevation. Now, as for the angle of depression is going down, basically. For example, your eyes are over here, and you're looking down towards the ground. This is the angle of depression. And notice the relationship between these two. This angle and this angle. These two angles are actually congruent because they are alternate angles, like what we've learned in high school math. These are alternate angles. So basically, if we have an angle of depression theta over here, then we have also another angle of depression theta, or rather, this angle is equal to the angle of depression theta that we have. So let's try solving the problem using this knowledge. It reads, the angle of depression from the top of a cliff to an observer in the ground who is 300 meters away is given by theta, where sine theta equals 21 over 29. How high is the cliff? Give your answer in exact value and in meters. Let's start. Let's draw our diagram first. So we have a cliff, and we have an observer here. Then the angle of depression from the cliff towards the observer is equal to theta. Then that would mean that this would be also equal to theta. And sine theta is equal to 21 over 9. So we now have our diagram. So what are we going to do? Well, other than this, we also know that the ground is 300 meters away from the observer is 300 meters away from the cliff. So this has to be 300 meters, and this is theta, and also this is theta. Now, we are looking for the height, and this is the height. Let's take it as each. Okay, so now we are looking for the height. And notice that the height is actually equal to the opposite, and the 300 meters is equal to the adjacent. And this unknown side is actually equal to the hypotenuse. Let's just take it of that. So let us notice that in order to solve for the height, we need to find a correlation with the height and the 300 meters. And that means a correlation between the opposite and the adjacent. And the only thing between the three trigonometric functions, three basic trigonometric functions that have a correlation of the opposite and the adjacent is the tangent theta, because it's TOA in the SOHCAHTOA. Tangent theta is equal to O over A. And we can have this as H over 300. However, we still don't know what tangent theta is. We're clueless what tangent theta is. But we were given what sine theta is. And sine theta has a value of 21 over 29. From here, we could recall that tangent theta is equal to sine theta or cosine theta over cosine theta. So we only need to solve for the cosine theta. And as in our previous exercises, we also have that cosine theta is equal to square root of 1 minus sine squared theta. And we are already given sine squared theta, which is equal to 21 over 29. So let's just substitute it, and we can now solve for the cosine theta. 1 minus 21, the cosine theta is equal to the square root of 1 minus 21 over 29 squared. So we're going to solve for that. Cosine theta is equal to this, the square root of 1 minus 21 squared is equal to 441. And 29 squared, if we're going to solve for it, I believe it's going to be equal to 841, if I'm not mistaken. Okay, so 841. So let's just simplify it at this point. We're going to have 841 minus 441 all over 841 is equal to square root of 400 over 841. And notice that both of them are actually perfect squares. So we could further simplify it into this. Square root of 400 is equal to 20. And as we've said, 841 is the square of 29. So that would mean that cosine theta is equal to 20 over 29. So let's just shorten it. Let's do it this way. Cosine theta is 20 over 29. Now let's substitute this into this one. Because we already know that tangent theta is h over 300. And when we are looking for h, we can just transpose tangent theta and get that h is equal to 300 times tangent theta. We just transpose this 300 and multiply it to both sides. But we don't know yet what tangent theta is, but we can solve for that using this, that tangent theta is equal to sine theta over cosine theta. And we already know both values. Sine theta, as given, is equal to 21 over 29, and cosine theta is equal to 20 over 29. We can just simplify it and get 21 over 20, and that's tangent theta. From here, we can now solve for h. H is equal to 310 times tangent theta, and we already know that tangent theta is equal to 21 over 20. So we can further simplify it into this 6,300 over 20, giving us h is equal to 315 meters. And that's it. That's our final answer. So the answer to this, how high is the cliff? The cliff is approximately, or exactly rather, sorry, 315 meters. So that's basically it. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Rainier Ginto from Syntax, paving your way to excellence.